differential relay. So here what is going to happen, let us say there is some equipment that needs to be protected. This is the power system equipment that is to be protected. So the power line is going to be like this. Now on either ends there is going to be one CT. Okay, this is CT1 and this is CT2. Now these two CTs, they are connected to an operating coil in this manner. Okay, this is the operating coil. Now when there is no fault, then what is going to happen? The current that is flowing here, let us say this is I, the same current will flow out of this. So this is also going to be I. Now these two CTs, they are identical. Okay, CT1 and CT2 are identical. This point is important. Now what is going to happen? They are going to give rise to the same current in the secondary, right? This is the primary, this also, and this is the secondary winding, right? So the same current is going to be introduced in the secondary windings of both the CTs. Okay, so let us take that as small I. Here also small I. So if you apply KVL at this point, what is going to happen? I will come from here and I will flow through here. What will be the current through the operating coil? It is going to be 0. Okay, current through operating coil will be 0 under normal conditions. Now what will happen when there is a fault in this equipment? Okay, whatever is equipment is in between the two CTs, a fault current IF is going to flow. So now if the generator is on this side, the source is on this side, then this current will flow like this and it will flow into the ground and no current will flow into this side, right? So in case of a fault, no current will flow in second CT. Okay, whether it is primary or secondary, the current is not going to flow. So you can draw this also for the sake of clarity. Here you have the fault. Okay, fault has occurred here. Now here you have one CT and here you have the other CT. These both are connected to the operating coil, right? Now the fault current is flowing through here and it is directly going here. What will be the current here? It is going to be 0. So here also I is equal to 0, but here current is going to flow. So we can take this as small if. So through this also the same current will flow because now the current through this is 0. Okay. So now when the current is flowing through the operating coil is going to give the trip signal to the circuit breaker. Okay, so that is how the differential relay will operate. So what is the thing that is here? What is the kind of relay that we have here? It is nothing but an overcurrent relay. If the current exceeds a certain value in this coil, then it will give a trip signal. Okay, so here we have overcurrent relay. Okay, and this entire setup that we have here, this is called the differential protection scheme. Okay, and in differential protection scheme we are making use of the overcurrent relay. One important thing that you can see here is the differential relay is going to operate only when there is a fault in between the two CTs. What if there is a fault somewhere outside, like if there is a fault here, then here fault current will flow, here also fault current will flow, then again the operating coil there will be no current. Okay, so it will not operate. So that is one of the basic characteristics of the differential relays. You can write differential relays only protect the equipment connected between the two CTs. Okay, and this is also sometimes referred to as Merz Price protection. So Merz and Price are two different scientists who have proposed the scheme of protection. So that's why it's often called as Merz Price protection. Now one basic limitation in the differential relay is that the two CTs should be exactly identical. Any small change, any difference between the two CTs will result in a current flow through the operating coil, non-zero current flow. Okay. So if that is going to happen, then the relay will operate, which is not desired. Okay. So in order to address the problem of unmatched CTs, we are going to go for a slight modification. Okay, so what is that modification? We are going to make use of an restraining coil. This is the operating coil and here we have the restraining coil. Both of these are restraining coils. Okay. So half of the turns are going to be here and half of the turns are going to be here. Like if NR is the number of turns of restraining coil. So here in the diagram we are showing it as separate, okay, but it's actually a single coil, but here there is going to be a midpoint tapping kind of a thing. So that here we have NR by 2 turns and here we have NR by 2 turns, okay. Now the same current I is flowing in the transmission line, but in CTs, secondary of the CTs, different currents are going to be induced, okay. So if here the current is I1, then here if current is I2, then what will be the current through operating coil? This is going to be I1 minus I2, okay. And what will be the current through restraining coil? This is also going to be I1, right, and through this half it is going to be I2, okay. So through one half current is I1, through the second half the current is I2. Now the restraining torque, this is going to be proportional, the torque is usually proportional to the ampere turns, okay. So I1 into NR by 2 plus I2 into NR by 2. This is the restraining torque. Okay. So you can write this as TR will be equal to some constant K I1 plus I2 by 2 into NR. Then what about the operating coil? The operating coil torque is given by operating torque T naught will be proportional to what? I1 minus I2 into N naught. So here we have N naught number of turns for the operating coil, okay. So here also if you take the same constant of proportionality, this is going to be K into I1 minus I2 into N naught. And what will be the total torque? The total torque will be operating torque minus the restraining torque, right, and this should be greater than 0 for relay to operate. So if you substitute the corresponding values here, you are going to get I1 minus I2 should be greater than NR by N naught into I1 plus I2 by 2. So you can see that this is the current through operating coil, right. So the current through operating coil should be greater than a certain value. Only then the relay is going to operate, otherwise it will not operate, okay. Therefore relay will operate only when the difference I1 minus I2 exceeds a certain value, okay. So this kind of the differential protection, it is called biased or percentage differential relay.